Welcome everyone. You've made it to the last video of the first week of e-learning. Congrats. I don't know at the time of this recording what next week is going to look like, but regardless, okay, hopefully this week wasn't too bad. All right, we've kind of gotten to the swing of things. Today we're going to be talking about segments some more, all right, and specifically measuring segments, all right. So we're going to start with just some things to know, go over some definitions, do a couple practice problems, do a couple examples, and then your practice problems will be on the second page. This is what we're going to do in class, so we're not going to get to this during this video. But we're going to go ahead and start up here. So first thing, so if you just see like AB like that with no mark on top, right? That is defined as the length of segment AB. So for example, you would see that like in an equation, right? Just AB. That just means the length of the line segment AB. So that's going to lead us into a postulate that we're going to learn today, right? And remember, a postulate isn't something that we need to prove. It's just kind of common sense, kind of something that we accept as true. So the segment addition postulate says if B is between A and C, then AB plus BC equals AC. All right. And that might look a little complicated, but with a picture, I think it makes sense. So if we draw a picture, all right, for this, so we draw line up point A all the way to point C, and we put point B somewhere in the middle, all right, then what that's saying is AB, so from here to here, right, plus BC, so that's from here to here, that's equal to AC, which is the whole thing. So essentially what this means is the parts, right, add together to make the whole line segment. And I think you kind of know that, right? So we can actually use this to solve some problems. So I'm gonna show you a couple examples. So the first one says, Y lies on a line segment in between the endpoints X and B as shown below. All right, so we've got X, we've got Y in the middle, and then we've got Z. So it tells us that XY is equal to 6. So we're gonna go ahead and label that, all right? And then it also tells us that XZ is equal to 25. That is the whole segment. Ooh, and then it says, what is the length of XZ? That's wrong. That should say YZ. That's my fault. All right. What is the length of YZ? So basically, so they gave us one of the parts, all right? They gave us this part, and they gave us the whole thing. So now they want to know, all right, what is YZ? Okay, so we're going to create a little equation using the segment addition postulate, all right? So the first part is XY, all right? So we've got 6. The second part is what we don't know, that's YZ. So 6 plus YZ equals the whole thing, which is 25. And this is very easy to solve, right? Just subtract 6 on both sides, and we get YZ equals 19. And that's it, okay? That's your answer. So YZ is 19. So you can kind of see how this works, all right? So this was kind of an easy one. To make it a little bit harder, right, we can actually start introducing variables. So this is why we started practicing solving equations earlier this week, because you're going to have to start doing it here. So for this question, it says, the diagram below, the length of AC is 33 centimeters. So they told us the whole line segment is 33 centimeters. And then it asks us, what is the length of AB? Okay, so AB is this part right here. So again, in order to do this, we're gonna have to create an equation that then we're gonna solve. So remember, in the segment addition postulate, the pieces, right, the parts add up to make the whole thing. So our first part right here is 2x minus 4. Our second part is from B to C, so that's 3x plus 2. So we're going to add that into our equation. And then that is going to equal the whole thing, which is 33. And now we can solve this. So we've got some combining like terms to do, right? We've got 2x plus 3x, that's going to equal 5x. We've got negative 4 plus 2, that's negative 2. All right, and now we can start solving for x. So we're going to add 2 on both sides. So we've got 5x equals 35. Divide by 5. And we get x equals 7. Now, are we done? Okay, so remember, what did the question ask? The question asked, what is the length of AB? So all we did was find x, right? So we're not done yet. Now we have to take that and we have to plug that back into the AB length, which is 2x minus 4. So we know that AB equals 2x minus 4. We now know that x equals 7, so we're going to substitute that. 2 times 7 is 14. 14 minus 4 is 10. So AB equals 10. And now we're done. So make sure you're reading the question, right? Sometimes it might just say find x. Sometimes it might say find, AB. We could say find both parts, right? The second part's easy. It would have to be 23, right? So yes, that's how you would solve that example. So hopefully that made sense. All right, I'm going to shrink this a little bit. And I guess I should say this is 10 centimeters, right? Okay. So yeah, that's the segment addition postulate. So the last thing that we're going to talk about today, all right, is congruent segments, all right? So what does congruent mean, right? Congruent means same size, same shape. That's what congruent means. So when it comes to segments, all right, they're always the same shape. So it just means they have the same size or the same length. So the way that is shown is with a little line, all right, going through the segment. So if we have segment AB, all right, and we have another segment that is CD, all right, in order to show that they're congruent, we would put a little line right there, okay? So those segments are congruent. If you had multiple segments and so let's say we had 2 more segments that were congruent to each other, we would just make 2 lines, and keep going if you needed 3 lines, 4 lines, and so forth. So that's how that is shown. So if you're looking at a picture, like for example, our example, right? These lines right here means that the segments are congruent. And so the symbol for congruence is not just an equal sign, okay? It's an equal sign with a little squiggle on top. All right, so that means congruent. So that's another way I could tell you. I could just tell you, AB is congruent to CD. And so if they are congruent, all right, that implies then that their lengths have to be the same. So if AB is congruent to CD, then the length of AB is equal to the length of CD. And so again, you can use that to solve problems. So we're going to look at an example here. All right, so you can see the symbol typed out, right? So they're telling us EF is congruent to HG, and so it says what is the length of the segments. All right, so they give us these two equations. So we've got 9x minus 12, and we've got 5x plus 8. So since we know they're congruent, that means we can set their two lengths equal to each other. So we're going to create an equation, 9x minus 12 equals 5x plus 8. All right, and now we can solve this. So we're going to go ahead and solve this equation. All right, we're going to subtract 5x from both sides because we always want to subtract the smaller x. All right, so 9 minus 5, that's 4x. And now we can start solving for x. So we're going to add 12 on both sides. So we've got 4x equals 20. Then we're going to divide by 4. And we've got x equals 5. So again, it asked us what is the length of the segment. So now we're going to take that and we're going to plug it back in. You don't have to plug it in twice because you know that it's going to be the same number regardless. So you can just plug it into the one that looks easier. All right, I'm going to plug it into 5x plus 8. So HG equals 5 times 5 plus 8, which is 25, which is 33. So both segments are going to be equal to 33. All right, so we've got HG equals 33, and we've also got EF then would equal 33. So that's all we're going to talk about today. All right. Hopefully you understood this. If you have any questions about any of the stuff that we talked about here, all right, make sure you ask them at the beginning of the Zoom session. All right. I'll go over any of the stuff that you want more in depth, answer any of your questions, and then we'll spend the rest of tomorrow's Zoom, all right, doing these practice problems. So again, if you have any questions, make sure you write them down, think of them before class, and other than that, have a great day.